complex numbers with our college algebra classes, and clicking on assignments. I'm accessing it through Pearson MyLab. This is assignment number 2. Notice we have 3 media files here that you have to at least click to get the green check. You're here today, so hopefully you won't need to, hopefully you'll get it from our lecture today and you won't need to watch those videos. But either way, there are 3 of them.
That's from
This is from January 23rd, 2023. Oh. Uh-oh.
What did you do?
Nothing. Nothing. I'm just making sure it's going to play. Oh, I had somebody from one of my online classes, and I'll mention this to y'all. There are 2, I guess this person wasn't familiar with YouTube. With YouTube, the YouTube player has its own volume control. Well, what's happening there? There. And your device has a volume control. So you have to make sure that the volume is up on your device as well as on YouTube play. Okay? So make sure you have your volume. But if you can't find it, email me and I'll tell you what's wrong. Playing it through the little finger.
Through.
There.
Okay.
And there's the one from Pearson with all the bells and whistles. It has
delay mark?
Let's see. Earlier I was talking about how fast it was today. You see, I spoke too soon. Oh, there she is. But even if you don't watch it, you still gotta click them to get the green check.
And at this point, what's your grade?
16.67, but notice now it'll let you click the homework problems. But you got to click those media files first before you can access the homework, even if you're not going to watch them.
Now, let's just sort of briefly review what we did the last time.
I am, don't worry.
Oh, okay. Switch places. Set the other microphone on.
Okay, remember last time we were simplifying square roots. We talked about perfect squares, the ones whose square roots are positive whole numbers. And we wrote out some perfect squares, realizing there are infinitely many. And then we reduced square roots of numbers that are not perfect squares. And let's see, we multiplied square roots, and we discussed like radical terms. They'd have the same radical and the same number under the radical. There. And I might need to, I know I could do a technical zoom, but I think that's better. Like radical terms, same radical, same number under the radical. We added and subtracted radical terms. We divided square roots by rationalizing denominators, and I think that's where we ended. Today we're looking at complex numbers. I want you to consider, let's consider
Common mistake. Square root of negative 144.
Yeah, here's a common mistake. The square root, I'm going to say consider the square root of negative 144. A common mistake is for people to say, well, what's the square root of 144? What can you square to give you 144? 12. And since it's negative, people stick on a negative sign. We know that's not right. Stop and think. If you take negative 12 squared, that's negative 12 times negative 12. Negative times negative is what? A positive 144. It doesn't matter whether it's a positive or negative. When you're squaring it, whether it's positive or negative, when you square it, what sign are you going to get? A positive number. So we would say that the square root of negative 144 is undefined using real numbers. A real number is any number that can be labeled on a number line.
All those decimal numbers that are there.
Any negative number, fractions, square roots of positive numbers, those can all be labeled on a number line, and hence they're real numbers. But something like the square root of negative 144 is not a real number, because no matter what you do, if you take a real number and square it, the result's going to be positive. So we're going to define a new set of numbers. This new set of numbers is called the complex number system. We're going to start off by denoting, we're going to denote the square root of negative 1 using a lowercase letter I. Now, I stands for imaginary. And any number that has an I stuck on it is called an imaginary number. And using imaginary numbers, we can take something like the square root of negative 144. And I want to make a note, these imaginary numbers are called imaginary numbers because you can't label them on a number line. There's no sense, the traditional sense of ordering. What's bigger, 5i or 6i? Well, we know that 6 is bigger than 5, but in terms of imaginary numbers, that's meaningless. You can't say which one's bigger, 5i or 6i. They can't be labeled on a number line. But let's start off, let's go back to that square root of negative 144. The square root of negative 144, here's how I'm going to think of this. I'm going to think of it as the square root of 144 times the square root of negative 1. The square root of 144, we've already said, is 12. The square root of negative 1, we're denoting with the lowercase letter I. So, using imaginary numbers, we can denote the square root of negative 144 as 12i. I guess the short version of this is to simplify the square root of a negative number. Simplify it as if it were positive. But then you're going to have to stick on an I. For example, number 1.
It's not fast.
I just spoke too soon and talked about how fast it was today. But I think that's the college's network. I don't think it's my lab. It's just, there it is, number 1.
Some of y'all might be able to just say the answer to this without writing anything down.
Okay. I said that we would think of it as, switch it for me. Here's my thought process. Well, a negative number under a square root. You take the square root of the positive number times the square root of negative 1. Because 9 times negative 1 is negative 9. We know the square root of 9 is... But since it's negative, we stick on an I. If the number part is a perfect square, all you have to do is take the square root and stick on an I. I'm not going to show this step anymore right there, okay? So we'll type in 3i for number 1.
Use a lowercase I. When you're typing in Pearson MyLab, never hit a space key and never hit a capital I.
Okay, that's a good point. For typing in answers, you should not use capital letters ever. And you shouldn't
hit a space key.
Hit a space key. They do the spacing for you. Notice,
like here, I put a capital I and it sort of looks like 31. If you're entering it correctly, a lowercase I, notice how it italicizes and looks nice.
I think that if you put a 3 capital I, it will accept that answer at this point. But once we get to logarithms, you start using capital letters.
You're going to mess up all the spacing.
Not only that, they're going to count it wrong, the formatting.
Yeah.
So for our purposes, no spaces, No capital letters when you're typing in answers. Okay, number 2. The square root of negative 24.
Now, where's those perfect squares that you had written down?
Oh, I better find them, hadn't I? The square root.
Oh, by the way, towards the end of class last time, we mentioned, I think almost everyone had left, but we have a notebook. We buy a notebook, and we keep all of our notes in it. Why am I saying this? It would be such a good idea for you to do that. Why? Well, you might want to... Is that 24 a perfect square? Did you write it down? Yes.
Yes, I wrote it down.
There. Look through.
What do y'all think? Is 24 a perfect square?
Remember
that? No, it's not a perfect square. It'd be right there between 16 and 25. Well, what's the largest number there that divides evenly into 24? Hint, it's the only number there that divides evenly into 24. And remember, when I talk about a number dividing evenly into another number, I mean that the remainder is 0. Okay, so 4, here's how I'm going to think of it. I'm going to think of it as the square root of negative 4, that's a negative 4 times 6. How are we going to denote the square root of negative 4? We know the square root of 4 is 2, but since it's negative, we're going to stick on. What are we going to stick here beside that 2? Because of that negative, an I. And we're going to bring the square root of 6 over for the final answer of 2i square root of 6. We did the same thing we would have done if we'd been reducing the square root of 24 the last time. The only difference is you're picking up that factor of I. Now realize that I is not under the square root. And you have to make sure that it doesn't look like the I is under the square root. That's why it's standard practice. If you have an I and a square root appearing in the same number, you put the I in front of it. Now, if you're typing this with the I afterwards, you have to put the 2, the square root. You better make sure that you tab out from under that radical before you type that I. You should never have an I under a radical. And you should never have a negative. You should never have a negative under a square root. If you see a negative under a square root, the first thing you have to do is rewrite it using an I. So typing, I'm going to put the I in front with the 2.
But you see, watch out what he's trying to say, and you said it. Okay. Don't do this.
The I is now under the square root. If you check it, you're going to get it wrong.
Okay. So notice, they're trying to give you a little hint. But that I should not be under the square root. That's why it's standard practice to put the I in front of the square root. And if you don't like that, well, then make sure you tab out away so you're not under the square root. So 2i square root of 6. Okay.
Any questions? Just keeps getting easier and easier, doesn't it?
They haven't seen problem 3.
Okay. Negative 3 plus the square root of negative 27 all over 3. I just finished saying that if you see a negative under a square root, the first thing you need to do is rewrite it using an I. So let's rewrite the square root of negative 27 using an I. Is 27 a perfect square? No. What's the largest perfect square that divides evenly into 27? It's also the only perfect square there that divides evenly into 27. Okay, so here's how I'm going to think of it. I have a negative 3 plus, I'm going to think of that as the square root of negative 9
Might like it better.
times a positive 3.
Okay.
Oh, they might. Maybe I'll do
Yeah.
that in the next one. Now, how am I going to rewrite the square root of negative 9 times the square root of 3? How am I going to denote the square root of negative 9? 3i, and with this 3 here, square rooted, okay. I should have gone over. Oh, let's see. So, there are two different approaches to reducing a fraction of this form, okay? The one that I'm going to use, if you have an I on top, you have a fraction up there with an I, a sum or difference, and all that's on the bottom is a number. What I'm going to do is I'm going to split up. I'm going to take the negative 3 and put it over 3. I'm
Make the
splitting up
universal marks.
plus, I took the negative 3 and put it over 3. Now I'm going to take the 3i square roots of 3 and put it over 3. That's a blue 3i. Square roots of 3.
It doesn't matter. Green, blue, and black all look black to me.
Yeah, I need to switch out of that. And now, you can't cancel over addition and subtraction. You can only cancel if the operation involved in the fraction is, you can have multiplication or division, but you cannot cancel over addition and subtraction. But here we've gotten rid of that. Addition is sitting there in front. So we can simplify the first fraction and we can simplify the second fraction. I'll get us started. Negative 3 divided by 3 reduces to negative 1 plus. Realize that this plus right here is this plus here. The last time we made the remark, you can't cancel something that's under a square root with something that isn't under a square root. But look at these 3's. 3 divided by 3, 3 divided by 3 gives me 1. So we just have 1i square root of 3. Those 3's we were able to cancel for a final answer of negative 1 plus I square roots of 3. Any questions there? If we have a fraction with an I on top, the other way involves factoring, okay? Factoring out a common factor and canceling. And we'll do that when there's not an I on top, once we get to the quadratic formula. But for the numbers that have an I on top, we'll split up and cancel the fractions individually. The reason is, here we have a sum of a real number with an imaginary number. That's called a complex number, hence the name of this section. A complex number is any number that can be written in the form A plus or minus B times I. You have something that doesn't have an I, that's the real part of the complex number. This thing has an I, that's the imaginary part. And if that I were an x, negative 1 plus x times the square root of 3, you can't combine those. They're not like terms. Likewise, you can't combine the negative 1 and the I square roots of 3. Algebraically, this has an I, that thing doesn't. We're stuck. You put the real part first, and then the term that has the I on it. Any questions there? Now, they won't always reduce so nicely. Sometimes you'll have...
nice.
Oh, I think so. There's no fractions. All the fractions completely canceled out.
Let me try to type in the answer before we still have the internet. Okay, so I click here. then it's going to show me the boxes. I'm going to click.
And notice it says type the answer in the form A plus BI. Show them where I'm pointing at, right there. And that's what we have. We have A plus the BI. Well, the I's in front. That's fine.
Okay. So, oh wait, it's not a fraction. Why don't let me type a fraction? That was my mistake. I don't type a fraction. I'm going to just type, what is that?
-1
-1
plus I.
Oh, sometimes students say, wait, there's no I button. Well, just use the lowercase I on your on your square.
Sometimes they do have an I button on the hot
button. Yeah, the first
button,
one did.
But not always. I never used that I hot button. I just type an I from the keyboard. Also, pluses and minuses, you type those from the keyboard. They are not on the their toolbar.
Well, let's do another one like this. You just love fractions. That's what I've discovered after all my years. I just love to work with fractions. So these are really messy with the fractions.
Yeah. 12 minus, let's see, maybe I'll use a square root of, I'm using that red. Normally I try not to use red because I once had a student that was colorblind. The red was so blurry, and so I was like, okay, no red. But it seems to be black and red are the only two colors that show good on these videos.
What about this blue? This blue might work better.
Man,
I don't know.
What did I say earlier? If you have a square root of a negative number, you must reduce that, write it in terms of I before you do anything else. So I'm thinking about the square root of 512. Pull up that calculator of yours. Y'all think that's a perfect square?
Yeah.
Let's see, is it?
Oh, where's that little secret calculator of yours? Did anyone find one of those, I wonder?
Pull up the square. Oh, there.
Square root. No, it's a decimal. It's not a perfect square. Hey, I wanted to mention something. On my calculator right here, if I punch in the square root of negative 512, there's two error messages the calculator gives. Look at this one. Error, non-real answer. What does that mean? It's an imaginary number. This calculator, it's a TI-83 plus. It doesn't work with imaginary numbers. Most calculators won't work with imaginary numbers. I'm curious, what happened to your little Casio calculator that you had? I don't see it.
Well, let's think about 512 while he's putting around that there. What do y'all think? What's the largest perfect square that divides evenly into 512? If I really have no idea and I'm trying to work with an even number, I think to myself, hey, what if we divided it by 2? Maybe the number we get will be a perfect square. Let's check. 512 divided by 2. And I'll tell you, this is something about my lab. They're not going to give you the square root of 137,458. Well, what perfect square would you use there? The numbers that the program gives you are sensible numbers. You say, well, 512 is a big number. But look at what happens if I divide it by 2. 256. I think that's a perfect square. What's the square root of 256?
Oh, we didn't go all the way.
We didn't go. There it is, 16. Remember yesterday I stopped at 15 times 15.
By yesterday, you mean Monday.
Monday. But if I'd gone on, the next one would have been 256. So that's one of the hints that I'm going to give you. If you're just not sure, what perfect square divides evenly into that? If it's an even number, if it ends in 0, 2, 4, 6, 8, try dividing it by 2. The number you get might be a perfect square. So here's what we have. I'm going to do this with scratch work, okay? That's a negative 256 times 2. So we have a 12 minus, we have a 4. What's the square root of 256? 16. Since it's negative, we stick on an I, and we still have a square root of 2.
Any questions? How we simplified that square root of negative 512 to 16i square root of 2. Realize this is just simplifying square roots like we were doing on Monday. The only new thing is this I here. Okay.
Then split up. Remember I said if you have addition or subtraction, you split up. You put the first number over 4, you put that second stuff over 4. So we have 12 over 4 minus, realize this minus right here, that's the minus I'm writing right there. That minus is that minus there. We have 12 over 4. And then we have another fraction over 4. It's a 16i times the square root of 2. And now we just have number over number so we can cancel. 12 divided by 4 reduces to 3. Well, it'd be 3 over 1, so we'll just say 3. 4 goes into 12 3 times, minus. What's about to cancel here?
16.
Okay. 4 goes into 16. What are we going to have left here? 16 divided by 4 is 4. So we have a 4i square root of 2. Oh, I keep writing too close to the edge. That's 3 minus 4i square root of 2.
Now, what's a common mistake? People get carried away and do what? 3 minus 4. No, no, no.
Because you can't say 3 minus 4x is negative 1x because they're not like terms. Likewise, you can't do it here. You cannot combine the real part, the thing without the I, with the stuff that has an I.
So it's 3. Oh, let me move that calculator. So 3 minus 4 I
square root 2. Well, once again, that was a nice problem. Notice how the fractions canceled out. I still think that they're not going to always cancel out. Let's see. I was expecting to have one with fractions, but they all canceled out. Okay, this one. We'll be stuck with fractions at the end. Negative 20 plus the square root of negative 50 all over 60. One thing that's nice, well, first of all, okay, and where's the mouse? There it is. Is 50 a perfect square? Is 50 a perfect square? No. What's the largest perfect square that divides evenly into 50? Realize it's got to be less than 49. That 25. So here's how you're thinking of it. Here's how you're thinking. That square root of negative 50, I'm showing my thought right now. My thoughts. That's the square root of negative 25 times the square root of what? It just now dawned on me a moment ago. Tony told me or said, oh, y'all might like it better if I wrote it as two separate radicals. And I didn't pay attention to what he was saying, but Now that I'm thinking about it, yeah, I think y'all might like that better, right? The square root of negative 25 times the square root of 2. How are we going to denote the square root of negative 25? We have a negative 20 plus. So what did you say? What are we going to do with that square root of negative 25? I didn't hear you. 5i. When I say I didn't hear you, I really did. I'm not subtle. Oh, you said something wrong, so I'm going to give you a chance to correct it. If I say I can't hear you, I just didn't hear you, okay? I say that's the first sense to go, and I got to agree with them, yeah. And I suppose, if you have to start losing a sense hearing, yeah, okay. I ignore most people anyway, so.
And they ignore you.
Now, if that tea had come out of my nose, Tony, I would have left class and not come back. I would have said, I'm taking a sick hour off because you made me.
Move it down here.
Yeah, I'm going to write it down here. Yeah.
Has he taught?
What do y'all think I'm going to do?
Y'all finished it?
What am I going to do next?
Separate them.
Okay, separate the negative 20 over 60, the 5i squared to 2 over 60. So we have a negative 20 over 60 plus, that plus there is the plus that's there in the numerator. The second fraction will be a 5i square root to 2. And now we can reduce each fraction individually. Negative 20 divided by 60. That's going to give me a negative what? Well, 20 goes evenly into both of those. 20 divided by 20 is 1. 60 divided by 20, what are we going to have down here? I couldn't hear you. 3, I agree. Plus, we've got 20 divided by 20 is 1. 60 divided by 20 is 3. Now, what can we do here? What can we cancel, I should ask? Okay, 5 divided by 5 is 1, so the 5 is gone. 60 divided by 5 is 12. So we have I square root to 2 all over 12. Hey, can we cancel a 2 and get a 6 down there? What do y'all think? Can we do that? Can you cancel a number under a square root with a number that's not under a square root? No. So, any questions? Say it a little louder.
Oh, like
this red 5, the square root of negative 25. The square root of 25 is 5. Since it was negative, we stuck on the I. We had the 2 left over. Well, where did we get the negative 25 times 2? We're trying to write 50 as a perfect square times another number. And the largest perfect square that divided evenly into 50 was 25.
the only perfect
The
square.
only perfect square that divided evenly into 50 is 25. And 1 wouldn't change anything, so I didn't even consider 1.
Okay.
Did I answer your question? Any other questions? Okay.
I'm going to type.
Okay, we have a fraction, negative 1 over 3. You're putting the negative on top. You could put it out in front before you type the fraction bar. You'd still get the same answer, but look at where the cursor is. Is that what he wants? Does he want that plus in the denominator? No, so go back, and then you got to either tab out or click with your mouse. I use the right arrow.
There.
Do something to get out of that denominator. Either click with your mouse, use the tab key. What I usually use is just the right arrow. Now we have another fraction, so activate the fraction hot button again. We have an I square root to 2 on top.
2.
Then click down on the bottom and type the 12. Any questions?
Any questions? This is a fraction, a real number fraction, and then we have an imaginary number fraction there, okay?
In a little bit, we're going to have fractions like number 4 and 5, but you'll wind up with an I in the bottom. And what you're going to do is you're going to try to rewrite it so it looks like this problem here where there's not an I. Because once there's not an I on the bottom, all you do is you split up, you separate, and cancel the fractions individually. So in a little bit, by the end of class, I'll be reminding y'all, do you remember what we did when we had a fraction but no I in the bottom? We'll be taking the problems that have I's in the bottom, do some manipulation so it looks like number 5, and then we'll split them up.
Let's see. But now,
operations.
We have 3 of those fractions like that, 3, 4, 5.
Just
now,
like with square roots the last time, we performed the operations. We multiplied, we added and subtracted, and we divided. We're going to do the same thing with complex numbers. We're going to multiply them, we're going to add and subtract them, and we're going to divide them. If I remember correctly, the first thing they do is multiplication.
No.
So, it's addition and subtraction. Switch over. Addition and subtraction of complex numbers.
Oh, by the way, Tim's wonderful little Hasio that the student gave him, when you try to type in square root of a negative, it just says error, non-real answer also. So none of these
and that's good.
Work with
That's
imaginary
good.
numbers.
You're good.
I know. Mm-hmm.
Okay. Addition and subtraction of complex numbers. What you're going to see as we go through this algebra involving I, it's very similar to the algebra involving variables like an X. It's very similar to just the algebra of variables. For addition and subtraction of complex numbers, it's really nothing more than just combining like terms. Combine like terms. If we had the variable expression
EX, for example.
Oh, EX is for example. I try not to use my cursive script, but there's certain things I just can't break my habit. I still use a cursive EX. All those penmanship awards I've won through elementary school.
Oh, no.
Now, do they even teach? Did they start back teaching penmanship? Cursive writing? I tell you, I won them. I was great at that stuff. Let's say -5 plus 7x. Suppose we wanted to add that to 3 plus 15x. I'm just making up something to remind you of how you combine like terms. In most algebra classes, that's the first thing you do. In beginner algebra classes, you learn about variables and you start combining like terms. So hopefully you'll be able to help me combine these like terms. I look at the parentheses. You look and you ask yourself, is there anything there in front that I need to distribute? In this case, no. You could say, well, there's a 1 there, an invisible 1. Multiplying by 1 doesn't change anything. These parentheses are an unnecessary set of parentheses. We can just drop them to have -5 plus 7x. The second set of parentheses, there's no number there to distribute through. It's just a positive 1. You don't see a coefficient, so you assume a 1. Multiplying by 1 doesn't change anything. So you just drop the second set of parentheses. That's a +3 plus 15x. And then you combine the like terms. The like terms have the same variables and the same exponents. Well, we have constant terms, -5 plus 3. We can combine those two. What's -5 plus 3? The things without a variable. What's that going to give me? That's a negative 2, I agree. Now let's combine the x terms. We have a 7x plus a 15x. How many x's is that going to give us? That's going to give us, I couldn't hear you,
43.
20, I think it's a 22. I think it's a 22x. Do y'all remember doing that? Combining like terms. You remove the parentheses.
Wait a minute, Tim. Negative 2 plus 22. Why can't I write that as 20?
Because they're not like terms. That's like saying, now I'm not going to use that as an example. I thought I was going to use as an example. In order to combine algebraic terms, they have to have the same variables and the same signs. I mean, the same exponents. This has an x, that doesn't have an x. It's just like the things with eyes and the things without eyes.
Let's do one
that
to
has an eye, that doesn't have an eye. So you can't combine them. Likewise here, looking at number 6, we're adding two complex numbers. This is number 6. And we have the complex number, negative 3 plus 5i. And we're going to add to that the complex number 6 plus 9i.
Don't add that 6 and 9 into the 15. Those aren't like terms.
First thing I do, I switch over.
Sometimes students say, well, wait, why do we have those parentheses? They're not needed. All they're trying to show is here's a complex number being added to another complex number. A complex number is when you have a real number and an imaginary number together, but you can't really add it. You
Or
can't get
subtract
15. You can't get a 2 out of that. So,
Okay, the first set of parentheses, we look in front, there's nothing to distribute. So we just drop those parentheses. That's an unnecessary set. The second set of parentheses, there's nothing in front except a plus. Well, that doesn't change anything. We just drop the parentheses. In a minute, what's going to happen? There's going to be a minus there. And we're not just going to drop the parentheses. We're going to have to do something about that minus. But with the plus, that's like multiplying through by positive 1. It changes nothing. So plus 6 plus 9i. And now we combine like terms. Let's combine the real parts, the thing that doesn't have an I. You have a negative 3 plus 6. Okay, negative 3 plus 6, that gives me a positive 3.
mark them out.
Okay, and I'm going to mark it out. I've combined those, okay? Now we have a positive 5i plus 9i. It's the same as if you had a 5x plus 9x.
$5 plus $9.
Yeah, $5 plus $9. You then have $14. So here, 5i plus 9i, you have 14 i's. So 3 plus 14i is my final answer.
And don't you know, at least one person would put 17.
17.
No.
You
No
cannot
17.
combine the real part and the imaginary part. Enter the answer.
Doing 3 plus 14 I. Check it.
Oh, it worked. Oh, okay.
Yes.
Okay, I gotta go a little faster to stop the, we're gonna get timed out. So, okay, we have, oh, look at this. We have 3 complex numbers. A minus.
1 minus 6i, then subtract 1, then subtract another.
Oh, it's subtraction. Well, shoot. Oh, let me rewrite
You
it.
did write subtraction.
No, I didn't. Minus and minus. Okay, there.
Everyone else is having less trouble. Like
1 minus 6i, and 5 plus 2i, and negative 5 plus I. Okay, let me make sure I don't miscopy this problem. 2i. Okay.
Any future electrical engineer, you're going to do a lot of stuff with these imaginary numbers. But,
Okay. You see, I messed up. I put a minus and a plus there, so it's 2 minuses. First thing we do to add or subtract complex numbers, we remove the symbols of grouping. Looking at the first symbol of grouping, there's nothing in front of it to distribute, so we just drop those parentheses. That's an unnecessary pair of parentheses, 1 minus 6i. The second set of parentheses, we look in front of it, and there is something there. That's a negative. That's like we're distributing through a negative 1. Multiply by negative 1, multiply by negative 1. As it is, when we just look inside those parentheses, I don't see a sign there, so we assume it's a positive. So we have a positive and a positive. What impact is that minus going to have? What's it going to do inside those parentheses? So it's going to become a negative and a negative. Negative 1 times 5 becomes a negative 5. Negative 1 times positive 2 becomes a negative 2. Don't forget the I.
Well, let's not
that minus in front.
Distribute
there and there. Distributing that minus changes the signs, so we have 2 minuses. Looking at the third set of parentheses, we have another minus in front. What's going to happen? Okay, so call it out. We're going to have a plus 5 and not a plus. That minus, negative times negative becomes positive. Negative times positive becomes negative. Hey, I don't see a coefficient on this I. Just like with the variable. If you see a letter and there's no coefficient, what do you assume the coefficient is? 1. So let's start combining the like terms. Let's combine the things that don't have i's. We have a 1 minus 5, that's a negative 4, plus 5.
Oh,
heck. Minus 5 plus 5, negative 5 plus 5, that's gone. What's the only thing we're left with? Just a 1. We combined the 1 minus 5 plus 5. Now let's combine the imaginary parts. We have a negative 6i minus 2i. That's a negative 8i. Negative 8 minus 1 gives us what? Negative 9, stick on the I. Negative 6 minus 2 is negative 8, minus 1 is negative 9. You will have to remember your sign number arithmetic. Sign numbers are going to follow us throughout this course, every class, every homework assignment.
And I'm going to go ahead and say it. Don't subtract the 1 minus 9. They're not like terms. Okay?
Punch it
When
in.
you see that, it's so tempting to say negative 8. Well, not for me.
Well,
but
not
for
my
other
students. My students are brighter than that, Tony. That's you that wants to do that.
Should be ashamed.
Okay, number 8.
Okay, I think we're going to start
Multiplication.
Multiply.
Okay. Switch over.
Hey,
Switch
I'm just wondering, do y'all in the back of your mind, when you see 2 parentheses like this, 4-letter word that starts with F, not a bad word, comes to mind? Foil, I heard someone say it. Okay, but You got to tell them a little something before you start the wonderful world of foiling.
Okay. Multiplication of complex numbers is, it looks like it's just algebraic multiplication. That example Tony showed you, it looked like a binomial times a binomial. You FOIL the thing out, okay? So it's very similar. Multiplication of complex numbers, it's similar to algebraic multiplication. There's one wrinkle, though. It is similar to algebraic multiplication.
Oh, y'all all called up?
But there's one wrinkle.
Doing great on time. It's just 3:01. We still have.
Right. Any questions? We
We
seem
can
to be
slow
going.
down if we need to.
Keep going back and forth to that page.
Yeah, so it doesn't.
Okay. I want to think about what I said at the beginning of this class. I said that I would be denoting the square root of -1. I said that the square root of -1 is denoted using a lowercase letter I, and that it's called the imaginary unit. The last time we looked at, let's see, oh goodness,
We had a rule.
we had a little
Languages
rule.
there.
Well, I like to have that sacred rule. Hey, do y'all remember this? Do y'all remember this little rule we came up with, that if you take a square root and you square it, you're left with what's underneath the radical? Y'all remember that?
That's a
we used
rule
it
we're going
for
to
the-
use all semester long.
The square root of 2 times the square root of 2, we were able to show mathematically that it reduced just to 2. Do y'all remember that? Yes? Okay. Suppose I square both sides of this equation.
So you
This is a little equation. I equals the square root of -1. When I do to one side of the equation, I got to do to the other side. I'm going to square both sides. Then I have an I square on the left side. What's going to happen on the right side? What's going to happen with this square and that square root? So what are we going to be left with then? Just a -1. Good.
circle it and put a red star.
I'm going to box it. Oh, you want a red
A box
star?
is a three-dimensional figure, so
I'm gonna rectangle it. Okay?
yeah, it's not a circle, but it's
Okay.
not a box either.
Mhm.
Box is three-dimensional. You get
This
boxes
is going to
from
be
Amazon.
important. You should never have powers of I in your final answers. I guess y'all, this is actually sort of amazing. We can take an imaginary number and square it, and the result is a real number.
I can tell they're
That
amazed.
-1 can be labeled on a, you can't label the square root of -1 on a number line, but you can label -1 on a number line. So the important thing is you should never have powers of I. You can have an I in your answer, or you may not have an I, but you can't have things like I to the 5th, or I to the 6th. You
Or
can't
I
have
squared.
I squared, using the fact that I squared is equal to -1. Consider this, okay? Suppose we had I to the 5th power. That's 5 i's. 1, 2, 3, 4, 5. We have 5 i's being multiplied together. I times I, that's I squared. Well, what does I square equal? I times I is I squared. What does I squared equal? -1. So we have a -1 times, hey, look at this. We have another I times I. What's that going to equal? Another -1 times another I. Look at what we've just done. We've taken I to the 5th power. We're able to reduce it just so that it's I to the 1st power. What's -1 times -1? It doesn't get any nicer than that. -1 times -1 is just +1I. Powers of I can be either reduced to just an I to the 1st power, or produce a real number where there's not even an I. But the point is, never leave powers of I in your final answer. Never leave powers of I in your final answer.
So if you're thinking of that problem you saw, number 8,
God,
and you said, oh,
we
we're
could
going
have
to,
done every one of the multiplication problems in the time I've been talking about it. You see, I'm beginning to ramble. So I need to keep me
rambling.
Okay, this is number 8.
So we've already mentioned that it's going to be foiling, but what else has he said? If you have an I square, you better replace it with a negative 1. So
2 plus 6i
could I write
times
that as 8i? No, I can't.
8 minus 9i. We have 2 terms times 2 terms. It looks like a FOIL problem to me. Treat those i's, think, oh, just pretend, oh, the I is a letter, it's a variable, then it's a FOIL problem. You go first, 2 times 8 is 16, outer, two times a negative 9i, what's that going to give us? Negative 18i. Now enter 6i times 8i. 6 times 8 gives me a positive 48i. Last times last. Be careful with this one, okay? We have a 6i times a negative 9i. Positive 6 times negative 9 is negative 54. And what did you say about I times I? I square.
Tells you why that's I square and not just I.
You say over here we weren't picking up I squares.
Because we were adding.
5i plus 9i, we're adding. $5 plus $9 is $14. When you're adding or subtracting, the variable part, the imaginary part doesn't change. It's here you're multiplying. I times I is I squared. Positive 6 times negative 9 is a negative 54. But remember, we cannot allow powers of I to appear in our final answer. As soon as you pick up an I, a power of I, you need to make sure that you reduce it using the fact that I square is negative 1. So here's what we're thinking. We have a negative 54 times, what does I square equal? A negative 1. So here's my scratch work. We have a negative 54 times a negative 1. What's negative 54 times negative 1? What is this term about to become? A positive 54. When you pick up that I square, the I square is going to disappear, but that sign in front of it is going to do what? Whatever you have there, when you multiply it by a negative 1, it's going to change. Any questions on my logic? Because it's that step right there. We already know how to FOIL, but it's this step here, replacing the power of I with a negative 1 and rewriting it so that there's no I squared. Any questions? We're not through with the problem. We can combine like terms. 16 plus 54. What's 16 plus 54? So we have a 70. We have a negative 18i plus 48i. We're adding, so it's going to stay an I. It's not going to be an I squared. What's negative 18 plus 48? A positive 30. And that is not 100i. It's just 70 plus 30i. A plus BI. You put the thing without the I first, then you put the I term. Any questions there?
Don't get carried away with I squares. The only time you get an I square is when you're multiplying.
All the
I
other times,
times I.
all the other times, you're adding and subtracting. Negative 18I plus 48I is a positive 30I, not an I square. Only when you're multiplying will you pick up those I squares.
I wonder, instead of
Type in the
typing
answer.
in 70 plus 30I, if I went 100I, is it going to be smart enough or is it just going to say wrong? Are they going to be able to say, hey, don't? Looks like you may have, oh, I probably shouldn't have done that. I keep forgetting about the internet. Oh. Use FOIL, then simplify by combining like terms. Well, I would have preferred him to say use FOIL, replace I squared with -1, then combine like terms. But okay. So let me put the right answer in. 30 plus 7, no, 70
plus
30I. You ready to do another one like that?
Let's see, maybe there's not another one.
Oh.
Number 9. Oh, I like this one. Mm-hmm.
This problem, it looks different from number 8, but it's really the exact same type of problem.
And it's going to go back to something that we're going to run into throughout the semester. A binomial square, two terms, something plus something or something minus something being squared. You cannot just square and square. That 2 means that we have two factors of -7 plus 8i. The
Two
most basic
sets of parentheses.
the most basic type of problem-solving skill. You take a problem that you don't know how to work and you try to make it look like something you know how to do. We know how to do it. If there's two sets of parentheses, we FOIL it out. Well, that means that's saying we have two factors of -7 plus 8i, so just write it twice. No, equals. This is an equals. -7 plus 8i times -7 plus 8i. Y'all following my logic there? We're just writing it twice.
Now, FOIL and replace I squared with -1, right?
So, first, -7 times -7, that gives me a positive 49, good. Outer, -7 times positive 8i, that will give me a -7 times positive 8 gives me a negative 56i. Inner, now it's a positive 8i minus 7i. A positive 8i times -7. What was I saying? Positive 8i times a -7. What's that going to give me? Another negative 56i again. And now last times last. Be careful there. Last times last. Positive 8 times positive 8 gives me a positive 64. I times I gives me a I square. That I square is equal to -1. I square is equal to -1. So we have a positive 64 times -1. Who's my scratch word? What's that about to give me? A negative 64 or a minus 64. It's the same thing. Those terms that contain I square, all you do is drop the I square and change the sign to make it negative. Well, if it had been negative, we'd change it and make it positive. Are we through with the problem? No. We have 49 minus 64. What's 49 minus 64? Is that giving me a negative 15? Okay, so 49 minus 64 gave me a negative 15. What's negative 56i minus 56 more I? Don't say 0. These aren't going to cancel out. If they were going to subtract down, one would be negative. What would that have to be? A positive. That's not what we have. You're negative $56 overdrawn, and you just went and, well, back in the olden days, you could write these checks, and they wouldn't know that you didn't have the money in it. Our sister was a master of negative numbers. She couldn't do negative numbers in a math class whatsoever, but you could ask her, and she'd be, oh, I'm overdrawn by $532.17. She was a master when it came to her checking account at keeping track of how negative she was. They eventually asked her to close her account. So, negative 56 minus 56 more, what's that going to give us? A negative 112. Don't forget the I for my final answer. Negative 15 minus 112i.
The only time you see an I squared is when you're actually right up here.
Multiplying out. I
times
times I. You don't just pick up I squares randomly throughout the problems. Question.
That negative 64 didn't come down and then combine with the negative 15?
Oh, it did. 49,
Where?
and then the minus 64.
49 minus 64 gave me the negative 15.
Thank you.
Okay?
Let me see. Let me type in
Negative 15 minus
negative 15.
minus 112i. There'll be other times throughout the semester where we'll have a binomial squared. It won't have an I, it'll have x's. And I'll be reminding y'all, remember what we did on number 9 in assignment number 2? And I'll flip through the notebook. Remember what we did? We didn't just square and square. You got to write it twice, FOIL it out.
Let me see. Oh, good. Now, number 10, I bet is true.
Now, don't say anything, Tony. You're going to say something and give it away. I'll say something right now. You're not going to foil here. I said that that complex number multiplication is really just algebraic multiplication. So, what are we going to have to do here?
Starts with a D.
You're giving it away.
I just said it starts with a D.
What's the word? You're going to have to distribute. If that were negative 3x times a binomial negative 4 plus 8x, you distribute. That's what we're doing here. Let's distribute the negative 3i.
Oh, wait. Let me, Tim,
Oh, wait a minute.
I don't see what you're writing.
So we're going to distribute. You take the negative 3i times a negative 4. Negative 3 times negative 4, that gives me a positive 12i. Okay, what about negative 3i times a positive 8i? Negative 3 times positive 8, that gives me a negative 24. The I times I gives me I square. That negative 24 times I square, what's that going to become?
Positive.
A positive 24. Okay, that's a positive 24. You'll follow our logic there? Negative 24 times negative 1, that gave me a positive 24. But it's standard practice to put the thing that doesn't have the I on it first. Just like it's standard practice to drive on the right side of the road in this country. My car would run just fine if I moved over to the left-hand lanes, but it's not done. Generally, in this country, we drive on the right side.
And we put our real numbers before our imaginary.
That's
Is
right.
that what you're saying?
Yes, you put the real number before the imaginary number. Now, if you type 12i plus 24, they may take it.
Hey, let's
They
see.
may take it, but suppose it's on the test. If they don't take it and you type it like that, then they're gonna, they'll say, "Hey, that's not right." I wonder what they'd say.
I don't
But
know.
suppose on a test you typed it in reverse order,
What is it?
And it didn't take it. You won't know until you've submitted the test, and at that point you got the problem wrong. So just remember,
I'm just going to
always
see. Will they take it?
Okay.
I think they're going to. I think it's going to take it. I think it was already. No.
Okay. You
Okay.
see?
Okay.
It's equal. Look, they have a good hint for you here. Your answer is equal to the correct answer, but it's not in the correct form. So you need to make sure, always put the thing that doesn't have an I first.
Okay.
So put the 24.
What you're pointing at. You're pointing.
Always put the thing without the I first.
Okay. So 24 plus 12i.
Oh, goodness. This is when the break is supposed to start, but generally we try to just go right on through so that it doesn't slow us down and you don't forget what we're doing, okay?
So if you have to step out, and this is true at any time during the semester, if you're sitting in here and, oh my gosh, I just got a text message, my child is sick, I need to call something, just step out and do it, okay? Or if you need to go to the restroom or whatever, you know? We're fortunate that if I have to go to the restroom or make a phone call, I can walk out and there's someone else here, okay? But, you know, I don't think any of y'all have identical twins that are sitting there beside you, do you? I don't think so. I'm not usually that unobservant.
Oh,
Okay.
really?
I mean, I think I would know if there were two identical twins in the class.
-9 plus 8, 2 minus 4.
I thought I did.
Okay.
Of course, if they're fraternal twins.
And if you need to step out, just feel free to do so. I'm going to tell you right now, I'll be stepping out in a little bit, okay? I think I'll finish multiplication and then I'm going to go take advantage of the facilities. You say, well, I'm drinking so much. Yeah, that's
Stop foiling, Tim. This is nothing new.
I'm waiting for them.
Oh,
okay.
No, they're waiting for you. So get going, Tim.
What you've already answered the question. Is this like number 10? We don't have to foil, or are we going to have to foil here? We're going to have to foil because it's a complex times a complex. It looks like a binomial times a binomial. First, -18, -9 times 2, outer.
Plus 36.
Okay. -9 times a positive, -9 times a -4 gives me a positive 36. Don't forget the I. Enter. Positive 8i times a positive 2 gives me a positive 16i. And now the last times last.
Minus 32.
Okay. Positive 8 times -4. I agree with that. -32. I times I squared. And as soon as I finish that foiling step, I deal with the I squared. But I don't start combining stuff yet. I deal with that I squared. How am I going to change that -32 I squared? It's going to become a positive 32. Good. So now we combine. Okay, let's combine the things that don't have an I. We have a -18 plus 32. Let's -18 plus 32. That's a positive 14. We have a 36i plus 16i. What's that going to give me? Okay, it's going to be a positive 36 plus 36 plus 16 gives me a 52i. Okay, for my final answer. 14 plus 52i.
14.
I like the multiple choice questions. That there aren't any in this assignment, but there are some. They're multiple choice, and one of the distractors is 66i. See if they can trick people into doing exactly what Tony's been warning y'all against. You'd be surprised. Yeah, people would decide maybe it is 66. I better combine those. But y'all aren't going to do that. Well, for one thing, because We didn't assign any of the multiple choice ones. You're having to type it in yourself.
Oh, wait, y'all caught up? Are we ready for the last multiply one? Then after that, starting with 13, we'll be dividing.
Mm-hmm. This is number 12. 5 plus 7i times 5 minus 7i. Are we going to have to FOIL here? 5 plus 7i times 5 minus 7i? Or is this like number 10 where we just have to distribute? We're going to have to FOIL because it's 2 terms times 2 terms. So here goes. First, 5 times 5.
25.
25. I was waiting for them to answer. Tony. Outer. 5i times a negative 7i is
Negative 35.
negative 35i. Good. Inner. Positive 7i times 5i. So it's a positive 7i times a positive 5i.
35.
Side. Positive 35i. And now last times last, be careful. Positive 7i times a negative 7i.
Negative 49 squared.
Okay, a minus 49 I squared. What am I going to do next?
Make it a positive 49.
Okay. I think I'm very consistent. When I pick up an I squared, the next thing I do is get rid of that I squared. Okay? Using the fact that I squared equals negative 1. So what will I do next?
49 minus 25 equals 24.
35.
Wait a minute, it's not a minus.
25 plus 49.
5 plus 4.
Wait, I'm getting 25 plus 49. Do y'all agree with the plus? Yes, okay, so 25 plus 49, that gives me is that 74?
And I heard someone else saying, get rid of the 35.
Get rid of the 35? How are you going to do that? What's about to happen here?
Yeah.
Okay, here they have opposite signs. So they're gone. Negative 35i plus 35i. They have different signs. They just subtracted or canceled themselves out. The only thing we have left is 74. Well, a moment ago we had the same number in front of the I, but they didn't subtract out. Well, they had the same sign, negative 56i minus 56i. That became a negative 112i. But here, notice we have opposite signs. Well, how is that possible? How do we get those opposite signs? What caused us to have those same number part but opposite signs? If you look back at the original problem, the terms are the same. What's different?
Plus.
Those signs there. A plus there, a minus there. Numbers, complex numbers like that. They're the same parts, but the only thing different is the connecting operation are called conjugates. A plus bi and a minus bi are called conjugates. I'll tell you, and what's important about conjugates, if you multiply conjugates together, the only difference, you're going to have a positive I and a negative I with the same number, and they're going to always subtract out. The only difference is the connecting operation, and I'll say the product of two conjugates is a real number.
That's amazing.
That is.
Maybe you better say no I.
I'm going to make a note there, a parenthetical note. What I'm really saying is if you multiply those things together, there's no I in the product.
So
Do y'all buy that we can multiply conjugates and the i's are always going to subtract out? Maybe we should make up one more example just to
wait,
make
hold
sure.
on. Wait, 74?
Just 74.
Uh-huh. Let's pretend we want to do one more number 12, and I'll just, okay, I'm going to say a similar problem. There, okay, let's do this one. Just to make sure y'all have the hang of it. Are these things conjugates of each other?
Yes.
Are they the same thing except one is a plus, one is a minus?
Yes, okay, they're conjugates. Here goes. And if you look at view an example, they may give you a formula that you can use to find the product of conjugates. That's ridiculous.
Just
Why
fail.
having that separate formula when you can just boil it out and do it like that? First,
49. Okay, we go.
okay, outer 7i times negative 3i is positive 7i. Okay, I did first. That got me the 49. Outer positive 7 times a negative 3i is going to give me
Negative 21.
negative 21i. Inner positive 3i times 7 is going to give me a. Okay, so that's a positive 21i. And last times last, positive 3i times a negative 3i is going to give me a.
Negative 9 still.
I agree. Negative 9i squared. 3 times negative 3 is negative 9. I times I is I squared. What will I do next? Okay. When I pick up a power of I immediately, in the next step, get rid of it using the fact that I squared is equal to negative 1.
What else can you mark out there?
There's something else I can mark out in this line. What can I mark out? That negative 21i plus 21i, that's gone. What's the only thing we have left? 49 plus 9 gives me a final answer of 58. If you multiply conjugates together, what the outer product, the outer product and inner product are going to have the same numbers but opposite sides, and those I terms are going to subtract out. If you multiply conjugates together, there's no I remaining in the answer. Any questions? So we've added, we subtracted, we multiplied. All that's left is division. Division of complex numbers. You realize it's been 5 years since I had that surgery. For 5 years I've had my smaller bladder, and that's one of the things, you know. I'm going to switch over and I'm going to step out.
Oh, okay.
Okay, Antonio, take over. I'll be back in a few minutes. Okay, so this is the last topic in this assignment. We're going to divide complex numbers, and I'm showing that up there so you can see what I mean by division. I don't mean draw the long division bar or anything. By division of complex numbers, we just mean a fraction, and it has an I on the bottom. Remember when we were through with number 5, I said we're going to have fractions later that have an I on the bottom, and we're going to have to get rid of the I that's on the bottom so that we just have a regular number. And if we just have an integer down there, no I, let's see, switch over. I was deliberately trying to set up the division stuff, warning you. So what we're going to do with the division, we're going to make it look like this, where there's just an integer on the bottom. And once you just have an integer on the bottom, you split up over that integer and cancel. Okay, so the approach Tony's about to tell y'all for division of complex numbers, it's going to take the division problem and set it up so you have an integer on the bottom, and then you split up the way I was doing on problems 3, 4, and 5. Our strategy is going to be, I'll be right back. Well, we don't have a whole lot of tools, but what can we do with a fraction? You can always multiply above and below by any number you want except 0 when you're working with a fraction. So our goal is to get this rewritten so we don't have a complex number, no imaginary number on the bottom. Well, we just finished looking at some stuff where we didn't get a imaginary number. So how are we going to divide complex numbers? I'm just going to write it out and then try to justify. To divide complex numbers, I didn't win the penmanship award. My brother won it for years and years. I didn't. To divide complex numbers, here's what we're going to do. Multiply above and below by the conjugate of the denominator. There's that new word, conjugate. So we're going to take the denominator, change the middle sign, multiply above and below by that. And write down this problem. Okay, so we have 7, this is number 13. 7 plus 3i divided by 1 plus I. A lot of little applications for these imaginary numbers in electromagnetic field theory. You're not going to see a lot of applications of complex numbers in this course. It's way beyond the scope. So what are you doing? Well, you're at least learning a little bit about imaginary numbers. No applications. Okay, so we're dividing two complex numbers. We have a complex number on top and on the bottom. We're going to multiply above and below by the conjugate of the denominator. So remember what the conjugates are. You change the middle sign. So what's the conjugate of 1 plus I? 1 minus I. You write 1 minus I. Now I'm going to put parentheses around all of these because we're going to have to FOIL twice.
So division of complex numbers involves repeated multiplication. You're going to have to multiply out those numerators and multiply the denominators.
So FOIL out the top. 7 times 1. 7. 7 times a minus I. What am I going to write for that?
Negative 10i.
Y'all caught up with me? So we've done first outer, now the inner. 3i times 1, well heck, just a plus 3i. And last, we have 3i times a negative I. Well,
remember, that's like a 1
negative.
there in front of that I, so it's a positive 3 times a negative 1. That's where we got that negative 3 from. What about the I times I? I squared. What's he going to do right there?
Negative 5.
Make it a positive 3. So these are
There's negative 3 times negative 1. And I squared changes that sign. So we just have a plus 3. You know, kind of marked out that minus 3i squared and just put a plus 3 in its place.
Now we'll multiply the denominators. 1 plus I times 1 minus I.
FOIL it out.
First,
1 times 1 is 1.
outer, 1 times a minus I. Ooh, I don't like that. I'm thinking my purple is not dark enough. So we have 1 and a negative I. Is that what I heard? So it's first outer, and what about inner? I times 1, is that just going to be a, And then I times a negative I. Positive times negative gives us what sign? Negative, and I times I is? I squared. Well, we know I squared is negative 1, so what are we going to replace that minus I squared with? Negative 1. I'm thinking this minus I squared, is that going to be a positive 1? And what did I go ahead, what can I mark out also? From the denominator. Right. Okay, those I's are gone. The reason you're doing this is so that you just have a denominator that's a whole number. Do we have a whole number, a real number in the denominator?
Yes.
Yeah. What's the new denominator? 2, okay. Now, what about up on top? Let's combine like terms. 7 plus 3, that's 10. And then negative 7I plus 3I is negative 4I. Now this looks cleaner than numbers 3, 4, 5 because we don't have a radical up there. We just have the I and a single number on the bottom, so we split it up the way we did with problems 3, 4, and 5. The universal little marks to indicate I'm breaking it up. 10 over 2 minus, this is that blue minus, 4I over 2. I know some of y'all can do this canceling and skip the step I've just written here. What is it going to reduce to? 5. And then a minus 4 divided by 2 gives me 2I. Okay. Wow. So 7 plus 3I divided by 1 plus I is a 5 minus 2I. Using the division algorithm, let's see, A divided by B equals C means C times B is A. So here's the quotient. If you FOILed that 2 minus 2I, that 5 minus 2I out with the 1 plus I and combined all the terms and simplified, you get back the 7 plus 3I. That's what you found. 5 minus 2I, but multiplied by the divisor, 1 plus I, would reduce to 7 plus 3I. Now type that in so we can see if we got it right. 5 minus 2I. If the answer's wrong, it seems like it's a lot quicker. So I'm pretty sure it wasn't. Well, of course it wasn't wrong. Okay, here's another one, number 14. 7 plus I, all divided by negative 4 minus 2I. Negative 4 minus 2I. I'm going to lift up a little. Okay. Divide above and below by the conjugate. Excuse me, what did I say? Divide? Mm-hmm. Oh, I'm sorry. Multiply above and below by the conjugate of the denominator. So, with conjugate, you only change the middle sign. Change the minus in front of the 2. Do not change the minus on the 4.
all you're doing is changing the middle sign. So you're going to multiply above and below by -4 plus 2i. And why is that? Well, we're now going to just have a whole number in the bottom.
If we do it correctly.
If we do it correctly, yes. So let's fraction bar and start foiling out. All ready to start foiling?
First, 7 times -4.
-28,
Outer, 7 times 2i plus 14i. Inner, +1i times a -4. -4i, I agree.
Any questions?
And last, +1i times a +2i. That's a +2i squared. 1 times 2 is 2, I times I is I squared. What are we going to do to that plus 2i squared? Okay, mark it out. That becomes a -2.
So +2 times -1, -2.
Now the denominator. First times first. -4 times -4 gives me a +16, I agree. Then outer, -4 times a +2i. -8i, I agree. -2i times a -4 gives me a +8i, okay. And then last, -2i times +2i. -4i squared. -2 times +2 is a -4. I times I is I squared.
Let's go ahead and replace this -4i squared with what?
+4, good.
I'll give you a moment to catch up if you've gotten behind. Are there any questions? We foiled out the top, we foiled out the bottom, and if we're doing this right, there shouldn't be any imaginary numbers left in the bottom, are there? No. You see what's happening? The 8i's are subtracting out, aren't they?
What do we have as our denominator now? 20. 16 plus 4 gave me 20.
What about the top?
Combine the things without the i's.
-28 minus 2. Well, that's -28 plus a -2. That is
-30.
Now, 14i minus 4i. It's going to be +10, right?
And then, look, we have that fraction and just an integer down there on the bottom. So what do we do to simplify? Okay, we break them up. -30 over 20 plus 10i over 20.
-30 over 20 plus 10i over 20. The -30 over 20, I could divide each of those by 10, and what would we have? -3 over 2.
I'm afraid your blue pen's running out of ink also.
Plus 10 goes into 20. How would y'all reduce this? 10i over 20. 10 goes into 20. The 2 would be
on top or the bottom? I think it'd be on the bottom. 10 divided by 10 is 1, so we have a 1i on top. 20 divided by 10 is 2, so we just have 1i over 2. Any questions on my logic there?
You can write it as I over 2, or if you want to say 1I over 2, however you want to write it. You want to try typing it in. Negative 3 over 2 plus 1I over 2, or just plus I over 2.
Any questions on our logic? Any questions on how we reduce that last fraction there?
The smaller
Divide above
numbers
and below
on
by
the top, so it's a fraction. Okay? No,
Even the bigger numbers
even
on
the
top.
bigger, yeah, it doesn't matter. Huh?
Mhm.
This is a fraction and this is a fraction.
For testing purposes, if we put the 1, will we get it wrong?
I think they'll count it right. I'll check. Okay. We're typing a fraction, negative 3 over 2. Now, if you just do your fraction doesn't have any other operation involved, if it's just number over number, you could go negative 3 and then the little slash 2, and it'll automatically convert it to a fraction.
But be careful. The next thing, the plus.
Is this what I want?
No.
No. Do the right arrow, tab out of that denominator, or click with your mouse. But you've got to get out of that denominator before you put the plus, and then it is let's see if we put 1I over 2. I think it's going to count it right. Now, if you don't put the 1, I know it'll count it right, but I think, yeah. So that 1 is acceptable. Any questions there?
Oh, wow. We have one more to go. This is the last one of the week, so it's got to be the hardest.
And then, remember, we don't have class on Monday. It's Labor Day.
Let's see. 2 divided by 2 minus 5I. Is that it? So, real number 2 divided by the complex number, 2 minus 5I.
Okay, we can't have that I down there on the bottom. We need just a regular real number, an integer, so we can split up. So,
what am I going to multiply above and below by? The conjugate of the denominator.
2 plus 5I, I agree.
Write it down. 2 plus 5I.
You know, we're just going to have to invest in new pens, Tony.
I know.
Seems like they're all running dry.
And you know what's really scary, Tim?
What?
I think Agnes got these pens for us
Back in the old office.
right when we started the YouTube channel. The
Uh-huh.
same semester. So these pens are 10 years old. It
It can't be. We've replaced some
Not
and
this
stuff.
one. This is
Not
one
the-
of the original.
Okay, let's do it.
Not that y'all care the least bit. I'm just talking so y'all can decide what to do next.
Hey, are we going to have to foil out the top? What are we going to do on the top?
Starts with a D.
Starts with a D. Distribute. It's not a binomial times a binomial. It's not 2 terms times 2 terms. You just distribute that black 2 over the 2 plus 5I. What's that going to give us?
4 plus
I agree.
Hey, did we have any I squares on top? Say no. No I squares? Okay, that's really nice.
Now foiling out the bottom. We're going to have to foil the bottom because it's 2 terms times 2 terms.
So what are we getting?
First,
4
4, I agree. Outer,
plus 10.
plus 10I, I agree.
Now see that positive 2 times a positive 5I. It's a positive 10I. What's next?
Inner, negative 5I times a positive 2. Negative 10I, I agree. And last, be careful. Negative 5I times a positive 5I. Okay. And what's he about to do?
Make that a positive.
Okay. So we're going to drop that negative 25I squared. It's about to become a plus 25.
on the top, all we have is that 4 plus 10i. But what are we going to have on the bottom? 29? I think you're right. See, the 10 i's are subtracting out, aren't they? Mark them out. And then we have a 4 plus 25. I heard 29, and that is right. And we still have to do something else. What do? We split it up because we want it in the form a plus bi. We want the real part. It's a fraction, 4 over 29. We can't reduce it. Just leave it as 4 over 29 plus. Can we reduce that second fraction? Not bad at all. Any questions there? Type it in so they'll feel confident that I'm doing it right. Well, I can understand them wanting to make sure. What do I have to do before I type the plus? Get out of that fraction bar, and then I type my plus, and then I have a 10i over 29. Is that what I wanted to type? Yes. And look at that. It has we did have a 94.44, but where's the mouse? I don't see it. Y'all see it?
Right,
There it is. But now it's up to 100. Now realize we have it set, so these grades automatically are sent to Canvas, but it is slower. But the Pearson grade book, it records the grades as you go, though. But it may take a little while for them to send it over to Canvas, but it will get sent over. Okay. Any questions? If you had trouble setting up your account, or if you have a question, we have plenty of time. Otherwise, ready to go? Go, go, go.